Continuing with our study guide, problem 22, we're simplifying sine squared minus cosine squared over sine squared minus sine times cosine. The numerator can be factored into sine x minus cosine x times sine x plus cosine x, and then denominator can be factored into sine x. You factor it out, and then you have sine x minus cosine x left. So those two will cancel out, and then sine x plus cosine x, you can divide each term by sine x. So sine over sine, that's going to be 1, and then cosine over sine, that is cotangent x. That is your answer. For the second one, cosecant squared minus 1, again, that looks very similar to some Pythagorean identity. If you don't remember, that's what we're doing. Sine squared theta plus cosine squared theta equals 1. That's the one that we have to remember. And then to get cosecant, it's 1 over sine. So again, we are dividing everything by the sine squared. So you get 1 cosine over sine, that is cotangent squared, and then on the right you have cosecant squared theta. So if you subtract 1 from both sides, you will get cosecant squared theta minus 1 equals cotangent squared theta. So parenthesis equals cotangent squared theta. So now you're multiplying tangent squared times cotangent squared, and that has to be equal 1, right? Because sine over cosine times cosine over sine. Okay, find the exact value. Sine of 345 degrees, sine 15, 19 pi over 2, pi over 8. Those you would be using your addition and subtraction formulas, or half angle formulas, something like that. So let's start with the first one. There are different ways to represent this one. I'm just going to add 300 plus 45 degrees. Both of those are special angle formulas. So that means we have sine 300 times cosine 45 plus, I believe I'm doing it right, cosine 300 times sine 45 degrees. So sine of 300, that's down there on the unit circle, that's negative root 3 over 2. Cosine of 45, that is square root of 2 over 2. Cosine of 300, that is 1/2, and then sine of 45, that is also root 2 over 2. So our denominator, common denominator, is going to be 4. Root 3 over 2, that is root 6, and it's going to be negative. So I'm going to put it as the second half, and then 1 times root 2, that is root 2. So you have root 2 minus root 6 over 4. Let's do sine 15. I would like to do, well, let's do 45 minus 30. 45 degrees minus 30 degrees. You can use half angle formula as well, so that's another option. So here you have sine 45 degrees cosine 30 degrees minus cosine 45 degrees times sine 30 degrees. And that is going to give us square root of 2 over 2 times square root of 3 over 2 minus root 2 over 2 times 1/2, very similar to what we had in the beginning. We have root 6 minus root 2 over 4. Now on to the radians. So 19 pi over 12. 12 tells us, and it's going to be tangent. So 12 tells us that probably our denominators are going to be 3 and 4. And then we need to have something here and something here, and we're adding them, that we will end up with 19 pi. So I am thinking, so I'm thinking 19 is 16 pi plus 3 pi, right? So if I multiply this by 3, then I will get 3 pi, so it had to be just pi by itself. And this one, after I multiplied by 4, it would be 16 pi. So originally it was 4 pi. 4 pi over 3 plus pi over 4, right? 4 times 4, 16. 3 times pi is 3, so 19 pi over 12. So I have the sum of those two. and I'm going to use the sum of tangents formula. And the formula, okay, and the formula is tangent 4 pi over 3 plus tangent pi over 4 over 1 minus tangent 4 pi over 3 times tangent pi over 4. Okay, tangent pi over 4 is 1. That's easy. Let's see what's 4 pi over 3. Pi over 3, 2, 3. Okay, 4 pi over 3 is going to be right here, and its tangent of it is sine over cosine. The sine is negative root 3 over 2. Cosine is negative 1/2. So the tangent is just going to be square root of 3. So let's plug it in. Square root of 3 plus 1 over 1 minus square root of 3 times 1. So over 1 minus square root of 3. It would be very nice if we could rationalize the denominator, which means that we would multiply by 1 plus square root of 3, both numerator and denominator. If we do that, then we're going to get 1 plus root 3 squared, which is going to be 1 plus 2 root 3 plus 3. And then in the denominator, we're going to get 1 minus root 3 squared, which is 3. So let's see, we have 4 plus 2 root 3. 1 minus 3, that's negative 2. So you have negative, so I'm dividing everything by negative 2, right? Negative 2 minus square root of 3. So that's my answer here. Cosine of pi over 8. Let's see, that would be cosine of, actually I'm going to do half angle formula here. So it's going to be cosine, just to practice with it, cosine of 1/2 of pi over 4, right? And then for cosine of half angle formula, we would have to take our positive or negative, but pi over 8, it's going to be positive cosine. So it's square root of 1 plus cosine of pi over 4 all over 2. So we have square root of 1 plus root 2 over 2 all over 2. And we're simplifying it to get 2 plus root 2 all over 4, square root of that, which is going to give us square root of 2 plus square root of 2, like this, over 2. So we can get it in this form as well. And then we are going to be adding cosine 195 plus cosine 105. There is a formula for that as well. This one is going to be equal to cosine of half of the sum times cosine of half of the difference. So half of the sum, 195 plus 105, that's going to be 300. And then degrees over 2, and then cosine half of the difference, 195 minus 105, that's going to be 90 over 2, which we simplify to 2 cosine, what is it, 150 degrees times cosine of 45 degrees. And those are special angles as well, right? So 150, that's going to be over here. Cosine is negative root 3 over 2, and then cosine of 45 is root 2 over 2. So we're going to end up with negative root 6 over 2. For this one, also we have a formula. This formula is going to be, let me erase this guy. So this formula is, let's see, 1/2. And then we have to do cosine of a minus b. And then we will be subtracting cosine of a plus b. All right, 7 pi over 12 minus pi over 12, that's 6 pi over 12. 6 pi over 12 is just pi over 2. And cosine of a plus b, that's going to be 8 pi over 12. I'm not even going to bother multiplying those because I know that cosine of pi over 2 is just 0. That's it. Oh, 8 pi over 12. Continuing with our functions here, sine of u plus v. Again, we know that it is sine u sine v, sorry, cosine v, cosine v plus sine v cosine u, which tells us that we would have to find the other the counterparts of those. So we'll have to find cosine u and sine v in quadrant 2, and then we will use the formula for this one as well. So if sine u is, we're in quadrant 2, okay, quadrant 2, like this. Sine is opposite over hypotenuse, 3, 4. So to find adjacent, we're doing 16 minus 9. Calculate the square root of that. That is going to be square root of 7, and it's negative. So that means that cosine u has to be equal negative square root of 7 over 4. Okay, cosine v. I'm going to use the same diagram, but I'm going to use this one. Negative 5 over 13. So this one is negative 5, and this one would be 13. So to find this side, we're doing 13 squared minus 5 squared. We're going to calculate the square root of that, and then we will 12 squared. So square root of that is 12. Or you can remember your 5, 12, 13 Pythagorean triple. 3, 4, 5 is not going to work because 4 is not the adjacent side. So this one is 12, which means that sine v has to be equal 12 over 13. Okay, now all we have to do is just plug in the numbers. Sine u is 3 over 4. Cosine v is negative 5 over 13. Sine v is 12 over 13. Cosine u is negative root 7 over 4. So once we simplify that, we can simplify anything here. So it's negative 15, 4 times 13, that's 52. And then we are subtracting 12 square root of 7. So we get something like this.